Okay, we are starting here because this is where we ended yesterday. Okay. I'm not sure how much time was left over when the announcements came on and stuff, but basically I wanted you to actually try to use your brain to get through this because yes, I know you end up with a fraction and a fraction, but you have got to get to a point where you don't let stuff like that just fry your brain. All right. So we're going to start off with n of, well, we start off with n of p of x. Okay. That means I'm going to take p of x and put it in here where all the x's are. So this will be 6 over x plus 4 minus 4. Okay. Does that look horrifically ugly? Yes. Is it a crazy difficult question? No. All right. So what happens with that plus 4 minus 4? They cancel out. They zero out. So those zero out. So that leaves me with 6 over x. Which, when y'all get to stuff like this, most of you just act like it is the hardest thing you've ever seen and you have absolutely no idea what to do. Okay, let me ask you, what if I give you this, what do you do? Okay, but like literally what operation do you do? You divide. It's division, right? Thank you for not saying 5, because usually I say, what do you do? People are like, 5. I didn't ask you what the answer was. To get 5, you divide, right? Because we know that that's what that means. That's what this means. 6 divided by 6 over x. So if you need to write this as 6 divided by 6 over x, there's absolutely nothing wrong with that. And then when you have fractions, especially if fractions are not your strong suit, I highly suggest you put your whole numbers over 1. Then you use your 4th grade math skills and tell me, what are the rules for dividing fractions? Keep, change, flip. 6 over 1 times x over 6, which is multiply by the reciprocal, is like the official words. But yeah, keep, change, flip works. And then the 6's cancel out, and you get x. And that's what we wanted. And that's what we expected. I skipped over the instructions this time, but because it says show that they are inverses, so that means you expect to get x. You just have to be able to get it legally. Okay? You good? All right. So then if I need p of n of x, now I'm going to take this and put it in here where this x is. So I'm going to get 6 over x minus 4, and then plus 4. Can I zero those 4's out right here, right now? No, that would totally not be legal. I got to take care of this fraction first. So this is going to become 6 divided by 6 over x minus 4. Put that 6 over 1. Keep, change, flip. 6 over 1 times x minus 4. Oh, nope. What did I do? I made a mistake. I forgot my plus 4 there. So when I do this, that's this part right here. I have to keep that. I still need that plus 4 there, or I lose it. Can't lose it. My equality wouldn't make sense. Okay, so now I can keep, change, flip. 6 over 1 times x minus 4 over 6. And then I still have that plus 4. These 6's cancel out, so that leaves me with x minus 4 plus 4, which is x. And that's what I wanted. I showed that they were both x. So now I can say n of p of x equals p of n of x, which equals x. Okay. Do not be hating on pre-cal when your problem is fractions, bless you, or when your problem is factoring or adding, whatever else it is, where we make most of our mistakes, right? Myself included. I mean, obviously I'm not perfect. All right, any questions at all? All right, so grab the notes for today then. Did you have any questions from yesterday since you had to watch the video? Not yet. I think we're okay. All right, so then we are here, and this is going on 58 when we are done. We are still talking about inverses. So if f and g are inverses, or inverse functions rather, then g of x equals f inverse of x. So I could say that you know, I have f and f inverse and they're inverses of each other, or I could just completely rename it as g or something like this. But if f and g are inverses, then g of x equals f inverse of x, and g inverse of x equals f of x, okay? Because they are inverses of each other. So from what we know about inverses, if xy is a point on the graph of f, then yx is a point on the graph of g, because that's what we're doing, is switching x and y, right? So then it says, with inverse functions, all of the x and y values are switched. So the graphical behaviors of x and y are also switched, which means that when we define the x and y values, or inputs and our outputs, we talk about domain and range. So our domain represents our x's, range represents our y's. So when x and y switch places, domain and range switch places also. And that's what this says. The domain of f is the range of f inverse. So if all I have is f, I find the domain and range, I know what they are for the inverse, I just got to switch them. Okay? We okay with that? All right. And then this says a continuous function. So continuous, meaning that I don't have any holes, I don't have any vertical asymptotes, I don't have any jumps in there. I can just put my pencil down, draw the whole thing. It will only have an inverse function if it is strictly increasing or strictly decreasing. So if I have a function and it just increases the whole time, then without me having to do anything else, if I know it's always increasing, I know that the inverse of it is a function. If I increase and then decrease and increase again or something like that, then this might be a function, but the inverse will not be. And that is because we know that both of these are functions because every x maps to exactly one y value, right? Or the inputs and the outputs. But here, if I look at this, each output is not mapped from a unique input because this output value has 3 different inputs, right? Does that make sense to you? All right, and so that means only if it's strictly increasing or decreasing. So then it says if a function changes, like I just said, it will not pass the horizontal line test. So we'll talk about that in a second because I'm not sure you've learned that before. And its inverse relation will not pass the vertical line test. So I realized I should have probably organized these notes a little bit differently because the next page is where we talk about the horizontal line test, but it's very simple, so I'm going to show you right here. If we have a parabola, it looks like this, right? If I graph its inverse, it looks like this, okay? That's a parabola and its inverse. And I know that my parabola passes that vertical line test, and the inverse fails the vertical line test, right? Make sense? We know that already. But let's say that I have a graph, maybe it's not this simple, and I have no idea what the inverse looks like, and I don't even want to graph it. But if I instead do the horizontal line test on the original, you see how the horizontal line here becomes the vertical line there? So if you just do the vertical and horizontal on the original one, you know whether or not the inverse would be a function. Okay, so since this function fails the horizontal line test, that would make this fail the vertical line test, therefore not a function. Okay, so that's what the horizontal line test is. Both of those, we'll talk about those and we can use those to understand things, but we cannot use them in our explanations. We have to be more formal with our words, but it at least gets you there to know which way to go with your words. So it's not evil or anything, it's just not as specific as we need to be. Okay, and then I'm going to hang on to statement 4 there because I'm going to come back to that in just a second. After we read the directions for this. It says, let f be a continuous function with selected values in the table below. It's really above. So remember, that selected values, that implies there are more points on there. And I know there are, because if it's continuous, that means that negative 2.5 exists and negative 2.6 and all that stuff. So that's not all of the points of the function, but it's some of them. Then it says, let g be the inverse of f such that g of x equals f inverse, and find the following if possible. Okay, so we know more than what it just told us, and we don't necessarily have to focus on that right now, but I need you to understand as we go through these things how a lot of times you know more than you think you do, and you know more than they flat out told you. So when I look at this, okay, I know my x's are increasing. I don't know what the function looks like. I don't know if it's a quadratic or a parabola, it'd be the same thing. Like, I don't know what it is, right? And I don't really care what it is. But just because I see it like this doesn't mean that I don't go from 3, 1, -1, then that -3. Like, who's to say right here we don't jump up to 5 and then come back down to -3, right? Because we just don't know what it looks like. But it says that g of x equals f inverse, and both of these are functions. If both of these are functions, could I jump up to 5 in between these two? No, because it would have to be strictly increasing or strictly decreasing. So I don't know what y value goes in here, but I do know it has to be between -1 and -3. Does that make sense to you? And it's not jumping back up. It's decreasing the entire time because the function and its inverse are both functions. Again, not something I had to overanalyze for this, but there will be other times where they don't flat out tell you, but because of properties, we have to understand what's going on. Okay? All right, so let's look at A. We want to find f of 0. So what is f of 0? 1. So then I want f of 1. What is f of 1? -1. So that means f of 0 equals -1. Any questions about where those numbers came from? If we get any, because we're not really calculating anything, we're just pulling numbers off of charts and graphs. So if at any point you're like, whoa, where'd you get that? Please speak up, because if I lose you right then, you might be lost for a while. All right. Oh, but look, g of -3. I don't even have a g on there. But I know that g is the inverse of f. I could rewrite a table, but I don't want to do that. So instead, I can literally just relabel it like this. Okay? Because the inputs and outputs just switch places. So then what is g of -3? Is it 6 or is it 4? Because for g, this row is my input and this row is my output. So -3 gives me 4. Okay, does that make sense to you? Okay. Then what is g of 6? -3, exactly. Everybody okay with that? Because with the inverse, you look at the output. All right, so then we need g of -1. What is g of -1? 1. And then g of 1 is 0. So g of -1 equals 0. Any questions at this point? All right. Now, f inverse of f of -2. So I'm going to rewrite it as f inverse of f of -2. I did that last period and somebody said, well, and you can rewrite it again. And at first I wasn't sure what he was saying, but do you know what he meant by that? G. Because f inverse is g. I could have rewritten this as g of f of -2, right? All three of those little statements right there mean the exact same thing, okay? And you don't necessarily have to rewrite these. I think at least writing it into one of these two, so put it in that correct notation there, I think that's probably good for you, but you don't necessarily have to. I'm going to leave it as f, though, because I want to talk about something. But f inverse of, okay, what is f of -2? 3, okay? And then f inverse of 3 is -2. That means that f inverse of f of -2 equals -2. What is f inverse of f of 5? What is it? Heard it. 5. Now, because this is continuous, we know an x equals 5 exists, and it would exist right here. I don't know what f of 5 is, but f inverse of f of 5 is going to be 5. Because look, we evaluated it. We evaluated -2 and got 3, and then we went the opposite way and got -2 back, right? Because the inverse undoes what you just did. So f inverse of f of a monkey is a monkey. Like, it doesn't matter what it is because you're undoing what you just did. 2 times 3 is 6. 6 divided by 3 is 2. Just go forward, go backwards. That's all it is. Walk forward 5 steps, walk back, you're right back where you began. But I'm not saying that you shouldn't look at your chart. Still do that. But I also want you to understand what's happening. All right, so then what is f inverse of negative 3. I heard 6 and 4 again. If this is F inverse, when I look at F here, the inverse means I'm looking at the output, and I get the input, and it is 4. You good with that? The input and output switch places when you have the inverse there. What questions we got? Anything? All right, so we have a graph here. Do not ignore the words that go with these things, okay? Because you got to make sure you understand what's happening here. So it says the function k is defined over the interval from negative 4 to 11. Okay, that's how much of it I have. This is the graph of k, because we're also talking about k inverse. They could give me a graph of k inverse and ask me about k. So that's why you got to make sure you know what you're actually looking at there. All right, so then it says, what is the minimum value of k of x and the minimum value of k inverse? Okay, before we even do that, if I have an ordered pair and it's asking about maximums, minimums, really anything, then the x value is the location and the y value is the value. Okay, so when it asks me the minimum value, I am not being asked for an ordered pair. I am not being asked for the x value. I am only being asked for the y value. The value, any kind of value of a function will always be the output. Okay, so let's label the maximum and minimum here. So this point is negative 4, negative 3, and this point is 11, 6. But if I want the minimum value of k of x, what is that? Negative 3. Good. So I know we switch x and y. I know we switch domain and range. Do you think maybe we also switch maximums and minimums? It kind of depends, okay? So let's look at what's happening here and think about what's happening before we just jump in and try to give an answer to something. First, if I was going to graph k inverse, which we're not going to, but if I was going to, what line does it reflect across? Y equals x. Okay, so let's sketch in, let's dot in that y equals x there. Okay, there's y equals x. Well, sort of is 0, but it's close enough, it's fine. So if I were to take that graph and reflect it over, then this point ends up over here, and this point ends up over there. So do the maximums and minimums on this one switch places? No, they don't. It depends on how the graph is related to the line. So it's not that it never does, it's that it sometimes does, it depends. So what we actually want to look at is take our maximum and minimum, and for k inverse, what those points would be, it would be 6, 11, and negative 3, negative 4. And then I can tell by those actual points, I don't have to graph the whole thing, those actual points, this would be my maximum value, this would be my minimum value, and that is negative 4. Okay? So in this case, was it as simple as switching those x's and y's? Yes, but it's not going to work exactly that way every time. Okay? And we'll look at one where it doesn't. But we good so far? All right. So then we need k inverse of 6. If I want to find k inverse of 6, what do I look at on my graph? Where do I look for 6? The y-axis. So this is 6. When y is 6, x is 11. Then k inverse of 4, because it's the inverse, my input is now my old output. So that would be a y equals 4 situation, where we get this right here is 6. What questions do you have? Anything? All righty, flip it over. Okay, so here, f is defined over this interval as shown above. So this is the graph of f. F inverse represents the inverse. So I'm looking for a maximum value. So let's start with writing out our ordered pairs here. So this one is negative 2, 7. And this one is 8, negative 3. Right? So for F inverse, those ordered pairs become 7, negative 2, and negative 3, 8. Then what is the maximum value of F inverse? 8. Because here, they did switch what was what. Because if I sketch in my line y equals x so I can see what's happening, you see how because of the way it's related to the line, this point ends up here and this point ends up down here, right? So they just happen to switch. So the easiest thing to do is just look at the ordered pairs and make sense of that. Okay, everybody okay with that? All right, so then F inverse of 3. What is F inverse of 3? 2. Yes. What is F inverse of 1? This what? 3. Good. Any questions about where any of those numbers are coming from? Would you say that's fairly simple? Okay, it is. But that I get wrong answers on those things all the time. And I don't know, I don't think it's because you just don't understand the concept. I don't know if it's because sometimes we're not paying attention to the fact that it's an inverse, or maybe it is that we don't understand and we're confused. I don't know. That's why I want you to ask me questions. But are we all good right now? Okay. Then it asks for the domain of F inverse. Well, if I want the domain of F inverse, what do I need from F? The range. Very good. So I want the range of F. Let's figure that out. So where does the range of F start? Negative 3. Good. And then we go to when? 7. Good. And then brackets or parentheses? Brackets. Okay, good. All right. Now, here's what we're not doing. We're not switching that negative 3 and 7 because this is a y value and this is a y value, right? So since that's y, what it changes to is x, but in that exact same order, and the domain of this is negative 3, 7. Okay. What questions do we have? Anything? We good? Okie dokie. All right. Function g is defined over this interval as shown above. There you go. Let g inverse represent the inverse of g. Values of the increasing function h are given in the table above for selected values of x. So again, we got more stuff going on there. Find the following if possible. Okay, and we're going to look at that if possible again. So we have g. It said let g inverse represent the inverse. Is h going to have an inverse function? And how do we know for sure whether or not it will? Well, but we don't necessarily have all of the points. Yes, exactly. Because it says values of the increasing function h. Now, I know that this doesn't say strictly increasing or always increasing, but if you have a function, if the function itself is referred to as increasing, that means it always increases. So if it's always increasing, that was one of the stipulations. As long as it's always increasing, then it will have an inverse. So then I know for a fact h inverse will exist. Does that make sense to you? That's how we know for sure. No assumptions being made anyway. Okay. So then g of h of 6. What is h of 6? 10. So then I need g of 10, which is what? Negative 1. So g of h of 6 is negative 1. Everybody okay with that? All right. G inverse of h of 0. What is h of 0? 3. Good. And g inverse of 3 is what? 4. Very good. Which on this one, Look at that. G inverse is 4. G of 3 is also 4. So if you got it backwards, you would have gotten lucky there, but be careful. So that means that G inverse of H of 0 equals 4. Alrighty. So H inverse of G of 8. What is G of 8? 0. Then what is H inverse of 0? -1. Since this is H inverse, I don't look at the X, I look at H because I want to go backwards. That's where I get that -1 from. So H inverse of G of 8 equals -1. Then H inverse of G inverse of -1. All right, what is G inverse of -1? 10, because here's -1, there's 10, right? Then what is H inverse of 10? 6. So H, let me scroll a little bit so I can write that. H inverse of G inverse of -1 equals 6. Look at D compared to A. We just did the exact opposite of it. We substituted in 6, got 10, then got -1. Then we did the inverse of -1, got 10, the inverse of that, and got 6 back. Just the complete opposite of that one. We're going to do one more right here that's not on there. I want to find G inverse of H of -5. What is G inverse of H inverse? No, I'm sorry. What is G inverse of H of -5? Okay, what is H of -5? -3, okay? What is G inverse of -3? Yeah, it's non-existent. Now, it actually very well might exist because we have G, but they've only given us G from -3 to 10. It might go past 10. I don't know because we don't have equations or anything. So for all I know, it does come down there and there is a number. But are we able to tell what it is? No, and we have nothing to go by to guess or anything like that. I don't even know that it's decreasing, right? Well, I guess I would because there's an inverse. So I do know it's decreasing, but that's the best I can do. But either way, I don't have enough information. On yesterday, we wrote something like not defined, I think, on one of them because the question said, say it's not defined if it's not, something like that. This says find the following if possible. So I would just put here not possible. I would just use whatever words they're using, just because that kind of is a little safer, I think, so that you don't just not. It's not possible. It's not possible for me to tell you. It might exist. I just not possible for. There's not enough information. We can't do it. Okay. Any questions at all? Alrighty. Grab your next sheet of paper. This is also going on page 58. Here's where I put the definition of the horizontal line test. So I do want to, I kind of showed you what it is, but I do want to talk about one more little thing. So it says, if every horizontal line intersects the graph of a function f at most 1 point, then f is 1 to 1. Okay? 1 to 1, I don't know if that's terminology that you have heard before or been used with you with inverses. And I'm not 100% sure that you have to use that word, those words on the AP exam, but this is about more than just the AP exam. If you have a function and the function has an inverse, that means it's 1 to 1. So to be 1 to 1, that means f and f inverse are both functions. Which also means that the x's don't repeat and the y's don't repeat. That's why it's 1 to 1, because there's only one of each. So that's what it means to be a 1 to 1 function. It just has to do with inverses. And some of this right here is a little repetitive, but sometimes we need to hear things over and over and over again. Graphs of inverse functions are reflections in what line? Y equals x, the parent function. Given a function f of x, the notation is f inverse of x. And then the domain of a function is equal to what of the inverse? The range. And then conversely, the range of the function is equal to the domain of the inverse function. Okay. Any questions at all? All right, so on these next couple, we're going to graph them, not just the inverses, but the original ones as well. Are you going to have to graph stuff by hand? No, you're not. But we're doing it on here because it is important that you understand the concepts. We talked about that a little bit yesterday. And I think seeing the graphs with this sometimes can also help you make connections. This is a square root function, right? Because it's got a square root in it. And we should know what our parent functions look like. We know that this is a parabola, right? This is absolute value. What does the square root look like? Use your arms. Oh, shoot. Very good. It's like this, like a teapot. Okay? So, looks like this. Good job, Angela. She got it right. She drew it in the air for me. Okay, so that's just the square root of x. But then we have two transformations here. That 3 means I go where? It's a liar. So I go where? To the left 3, and that 2 means I go down 2. So this point here that's at 0, 0, that point starts at 0, 0, but it goes to the left 3 and down 2, and that's one of the points you can plot. Okay? Now, for graphing purposes, like when you're in calculus and you need to have an idea of the graph and increasing, decreasing, that, even sometimes for us, we may not need any other concept. Now, don't do what I'm about to do. But it might just be that I needed to know that, oh, it's just something like that, just to have an idea so I know what's going on. We're going to plot a few more points, but at least knowing how things shift and what quadrant it's going to be in, those kinds of things, those can be very helpful without graphing a perfect graph. Just bare minimums, that is huge, okay? But I'm just going to give you the other points to plot. We're going to plot -2, -1, and -1, 0. No, we're not. 1, 0, I'm sorry. And then just do your best to make the little curve. It's not an art class. We just need an idea of something. We made an honest attempt to do it right. So something like that. Okay. Now, before we do anything else, for F, our original, we need our domain and range. Where does the domain start here? -3. Good. And we go to infinity. Do we include -3? Yes. Okay. Range, where do we start? -2. And we go to infinity. Where are you getting 0 from? You get it? Okay, good. All right. Yeah, well, you kept saying 0. I want to make sure you understood why it's not 0. Okay. Because we didn't finish there. Okay. All right, so there's the domain and range of the original one. That's what we just graphed there. Okay, so now let's find our inverse. So I'm going to call that y so I can switch them. So I'll get x equals the square root of y plus 3 minus 2. All right, so I know I'm going to have to eventually get that y out from underneath the square root. How do you undo a square root? Square. So should I square both sides right now? No, I could, but that'd just make my life a whole lot more difficult. What do I need to move first? The 2. So x plus 2, you don't necessarily need parentheses right there, but I did it anyway. Square root of y plus 3. Now can I square both sides? Yes. Okay, so we'll put my little squareds here. And then that'll give me x plus 2 squared equals y plus 3. Will this give me x squared plus 4? No. Okay? No. But I also don't have to multiply it out, so I really don't care what it's going to give me, right? I just want to make sure you know it's not x squared plus 4. So if I don't have to multiply it out, I'm not going to. I just need to move that 3, so this is going to give me x plus 2 squared minus 3 equals y. So that means that f inverse of x equals x plus 2 squared minus 3. Okay. Everybody okay with that? All right. Now, I want you to sketch in with like a little dotted line, sketch in your y equals x line. And let's go ahead and plot our inverse, which we could have done before we found the equation. But this point here that's at -3, -2 will be at -2, -3. -2, -1 will be at -1, -2. The point that's on the line, you can actually make a point there too, because it'll stay there even if you don't know exactly what it is. And then 1, 0 becomes 0, 1. So then we can sketch that in right there. Okay, now, you know stuff about functions, right? More than you actually probably realize you do. But this inverse function we just got right here, by the way it looks, what is that? What kind of function is that? It's a quadratic, right? And quadratics graph what? Parabolas. Is that light blue thing I drew over there look like a parabola? Looks like half of one. Okay, yeah. It's not a whole parabola for sure. But this equation implies an entire one. But remember, we had a restricted domain and range before we started, right? And so now, because I found the inverse, I still have a restricted one, but they switch places. So the domain here is -2 to infinity, and the range is -3 to infinity. And if you look at that with the light blue one, that's totally what's happening. So we don't get the entire parabola, we just get part of it. Okay? Now, think about this. If we did this the other way, and I had the parabola, and then we ended up finding the inverse the other way, when we got around to, we'd have to take the square root of both sides at some point, right? And then we'd end up with a plus or minus. Because I'd have to, if I had the plus or minus in front of this right here, then I would have both sides and I would have the parabola that looks like that. Because remember, this is what a parabola looks like. If I actually graph the inverse, I get that. But that's not a function. So sometimes what we do, and this I think was actually stated yesterday, but I know it didn't necessarily make sense right then. But if we want to have a function to be able to work with, we can restrict the domain. So when we restrict the domain right there and just use that part, then when we graph it, we just get that part, and then the square root part is a function. Does that make sense to you? Also, to point this out right now, it doesn't really come up a lot for us, but it does come up sometimes when you're working through things in calculus. But when it comes up for us, we have domain and range and we can make sense of it. But if I didn't have that, you notice how we decided our choice was to square both sides to solve it, right? When you square both sides as a part of solving things, in the end, you should always check your domain. Just like when you introduce the square root, you have to put plus or minus because you've affected what's going on. So sometimes when we square both sides, everything works out just fine. Sometimes when we square both sides, we get extra answers that don't make any sense, okay? And basically, we got half a graph that we don't get to use because of that restriction, okay? We good so far? Yes? Good? All right. Let's just at least get this one started here. So this is a cube root function. You may not know what a cube root function is. I think maybe I'll do them a little bit, but not much. But do you know what a cubic function looks like? We should know what a cubic function looks like, right? Looks like this, right? So the cube root is the inverse. So if I take that and reflect it in the line y equals x, I get a shape that looks like that. And knowing that much is important, and I'm going to show you why here in just a second, because I'm going to tell you which points to plot. I want you to plot -3, -2, -2, -1, and -1, 0. The first 2 points are the same as the first other ones. Yeah, exactly. So if you have no concept of what that looks like, and I give you those 3 points, you can do a lot of things with that, right? You can make a line. You can make part of an absolute value. You could probably make a lot of things. You can make a cube. Don't do this because it's wrong. But cubic looks like this. It goes through there nicely too, right? But that's not what we're doing here. We have to have a concept of what it looks like. And that is this thing that's laying down. So we're just going to sketch it in like that. Okay. And then, so for g of x, our domain, what's our domain? Good, negative infinity to infinity, good. And our range? Negative infinity to infinity, exactly. It's all real numbers for both. Okay, we get to use everything. Okay. Then I think I want to go ahead and stop here for today. We'll pick up here tomorrow. I'm going to go ahead and give you your assignment, though.